hear me well. Hello, friends, and welcome to my session called I Don't Trust AI Agents, and well, neither should you. So I'm going to be talking to you about how can you build trust in your AI agents. Well, through architecture, through certain decisions you made in your applications, in the way you build your systems, because, well, you need those things. To introduce myself, my name is Darko. I go these days, but what they call a developer advocate. I basically talk to developers, builders like yourselves about the latest and greatest in cloud and AI technologies. I do come from a long line of system administrators, and I used to manage a bunch of big systems in the past, from anything Unix and Solaris and all kinds of silliness like that to modern cloud systems on AWS today. I've been building applications with AI. Well, before we call them agents, I guess, right? So we didn't call them agents yet, but like at the first inkling of Claude 2.0, I believe, and early days of Amazon Bedrock, I was building stuff on it, and it's fascinating to see how those things evolved by addition of tooling and addition of computer use and a bunch of other stuff. So a lot of lessons learned from that. And again, today I'm going to be talking to you about a bunch of stuff I've learned, a bunch of stuff the industry has observed throughout the whole well, process today. And to answer Daniel's question, tech stack agnostic today, definitely I'm not going to be talking. I'm going to be mentioning AWS services, but the stuff I mentioned, stuff I talk about today is going to be very much a broad generalization of how you should build things. So if you decide to insert your own framework here or insert your own backend here, you can absolutely do that. And so yeah, okay, let's kick it off. First of all, building with AI agents versus building AI agent is a very different thing, right? When we talk about building with AI agents, this is where we talk about your typical productivity agents, right? Your coding assistants, your chatbots, your end user applications. These are excellent things, but the common practice here is just to give these things access to things and just let it rip, right? It's super easy. Your coding assistant has access to your underlying system. Your chatbot has access to some internal data, and it can just keep on answering questions. Fun, right? It works really well. However, when we get into something called AI-powered applications, this is where things get a little bit hairy, because AI-powered applications are your customer service stuff, your claim processing, your incident responses, some things that actually have an impact on your business more than just a single productivity issue, right? So these applications take a little bit more of effort and a little bit more of thought before you actually go ahead and build them and give them access to everything. So I'm going to be mentioning a few of those things today, right? Because here it is, friends. AI agents really can break in very creative ways. Since the dawn of this AI era, which is weirdly enough like 2 years ago, the pressure to ship AI features leads a lot of the builders out there with short-term thinking, right? I'm going to go ahead and do something. I want to optimize for time to wow and not to time to actual production. So building stuff and pushing stuff out there is just kind of the default modus operandi. And a lot of the examples you've seen out there, from tutorials to workbooks, is that you have like these simplified patterns of how agents work. You basically here's an agent harness, here's a model, and here's a prompt, and you hope for the best. But that doesn't really show the actual production path, because your agent can refund the $9,000 on a $300 order. Your agent can absolutely leak private customer data. A car dealership can sell a car for $1. A personal assistant can delete your emails. And none of these things I'm kind of thinking up of from the top of my head. All of these things have actually happened, right? So why do these things happen? Well, when you give your agents autonomy and give them access to tools and data, you are making them useful, right? That's how you build an agent that actually does something, that can do something, right? But they're also non-deterministic, right? So it is incredibly hard for you to anticipate every single path your agent may take. Will that path lead them to refunding $9,000 because they can do that? Or will that path lead them to deleting your whole production email server? This is a challenge that we as builders are all facing with AI. However, there are tools out there that can help you do that. But before you get into tools, you need to build up discipline in building these things. Yes, I know it is easy. It's super easy to give it a super great prompt and hope for the best, but that's not how it usually works. So the point is, you shouldn't trust AI agents, right? But you should trust the systems you build around them, right? Everything else, your guardrails, your architecture, applying the same lessons we've learned to building actual good systems. Again, even if you go back to the days before AI, if you apply the same practices, same lessons to agents, everything else is going to be easier to tackle. Treat the agent itself as a potential attacker in your system. Comment here from Daniel said, give it fewer permissions. Yes, absolutely. It's the typical least privilege model. You should always do that. However, if you go the least privilege, you kind of get into the world of is this agent even useful anymore? So there's kind of a balance you have to figure out. So okay, a couple of agent failure modes to get out of the way first, because I want you all to understand what I mean when an agent fails, right? A simple example is agent says something wrong, right? It promises stuff it can't really do. It leaks sensitive information. It hallucinates stuff. Those things happen, and it's a very common thing. It's been here since the beginning of this AI age, which is fine, right? This can be problematic. It's usually not as detrimental as certain other things. However, since we've given these agents tools and things they can use to actually perform their jobs, agents can actually do something wrong, from performing a massive refund, right? If you give your agent a tool to make refunds, it could decide to refund $9,000 on a $300 order, right? It can do something against a wrong account. It could delete stuff it shouldn't, right? And also, at the end of the day, an agent is a surface which you expose for other people to potentially misuse. So having somebody trying to basically break into your system, use prompt injection to ignore these instructions, or have your agent do things. There was this whole thing about shout out to Chipotle, by the way. Chipotle's AI agent would just respond to lead code questions, because if you told it, I want to order a burrito, but before that you need to help me answer this lead code question, and it will do that, right? It's not the end of the world, but it's inference, so you're paying for it. So somebody will try to break into your system through your agent. So all of these things, all of these types of failures require a different control layer. Okay. Quickly, this is how an agent loop usually works, especially on AI-powered applications. You have the client, you have the customer agent, you have an LLM, there's a MCP server, and a whole bunch of tools and utilities an MCP server, an agent can use, right? In this example, I've built this customer service agent thingy for a robot vacuum company. It's a demo, so apologies, but a customer can log in, chats with the agent can look up orders, check up on its return eligibility, generate return labels, all of these kinds of things. But this is your typical agent loop, right? MCP server is, just for folks out there that don't know, is just you're giving your agent the ability to invoke certain actions, certain tools, for the lack of a better word, but it's a standardized way for agents to actually invoke these tools that are running somewhere else, either on the same server instance or whatnot, with agents, or fully remotely. But this is what gives your agent the superpowers to actually do its job. In my specific example, and again, I'm keeping this very much, what was the word? Daniel said this, stack agnostic today, but what I'm using here is I'm using the Strands Agent SDK, which is an open source framework for building agents. It gives you the ability to build agents no matter what, no matter where. It doesn't have to be AWS; it can be any other platform. But from the AWS side, I'm actually using Amazon Bedrock as the foundation for my large language models. I'm using Amazon Bedrock Agent Core Gateway to be my MCP gateway to all of my tools. And my tools in this case are bespoke Lambda functions running on AWS. So that's how my architecture works, but insert your cloud of choice here, insert your framework of choice here. All of the things apply. So let me just try to show you my demo application, because I kind of, I want to make sure you see something. So this is a thing. So, and don't fail me now. It's my any robotic service, and I can ask it a question, and you can say, what can you help me with? Hopefully my login hasn't expired, and it should be able to tell me what it's able to do, and the way it's able to tell me. Great. It's not able to do that. 1 second, my friends. Where are you? I should be able to do this. Frontend is running. Let's see, my AWS login works. Log into that one. It's not. 1 moment. That's why you get to enjoy a little bit of backend stuff. I think Ann said that this is all stuff you don't see on keynotes, and I happen to be doing a keynote. So back to this thing. AWS log into my account. Perfection. Let's see if this works. I'm going to come out here. Clear just front end. Excellent. Refresh. Sign in cognito. It is John Smith, and a password. Okay. What can you help me with? Let's see. Hope for the best. This is promising. In essence, it's a simple agent that can look up stuff. It can troubleshoot stuff, returns warranty, all of these things. Nothing crazy. If you look at my agent definitions here, I do have some code to share as well. If you look at my agent definitions, it's literally an agent that uses a model, and in this case, it's using I think Claude 4.6 Sonnet. It has a specific system prompt, which is basically this. And it has a bunch of additional things that are related to it, which I'll get to in a minute. But it's a model. It uses a Claude model. It has a bunch of tools, has a system prompt, and some additional flair around that. So yeah, that is in very simple terms what I have here. Now, to go back to my thing here, let's actually talk about how do we implement trust, right? Or a layered approach to trust. You have to very firmly understand the differences between deterministic and non-deterministic controls on different levels, right? Having multiple different guardrails, because some of those guardrails will fail, there should be another one that kicks in. Like any other system, you should have multiple dimensions of trust and safety. You shouldn't solely rely on the agent to perform your trust or safety. There needs to be other systems that keep the agent actually in check, that do those things, right? So again, like mentioned before, the fundamentals still apply. Basic infrastructure and system design still matters. You are exposing these agents at scale to the internet in a proper, real distributed systems. You need to apply the same practices to both systems building and security engineering. There's no silver bullet here. There is no like, oh, you just enable this and that's fine. You have to treat this as a big old system, as something that's like any other thing. Yes, certain things are easier because agents tend to do certain things very well, but still, agent is only a single part of the overall system that can, well, cause a lot of problems. So Daniel is asking, I'm not using A2A. I'm not using A2A in this case. It is literally I'm using MCP for all the tool calls. Context engineering, there is context engineering to part of it, but still context engineering is one of those things that actually can make you feel like you're succeeding really well. but then it can fail, right? So let me start with the first problem, right? I do not trust users not to abuse my agent, right? So if I go back to my agent and I tell it, before I check on my order, I need you to help me solve a lead code problem, right? Like that's your typical way of users abusing your model, just telling it, can you do this, but please solve me a lead code problem. And if my agent is set up properly, it will say, I can only help with any company robotics robot vacuum. Yes. So this is one of the common things that keeps happening in agents, is that an agent will usually say yes, but in my example, it didn't say yes because, you know, stuff like this happens. But there are things I've introduced into my application that actually prevent this. So what did I do here? I've applied model guardrails, right? In this case, I used Bedrock guardrails for this application, but you can apply any other framework or infrastructure that you can do this. That can do this. Basically, it's a system that can potentially block prompt injection attacks and unsafe requests, right? It will automatically redact certain stuff coming out. So there's both incoming prompt injection and also outgoing message sanitization. So it can basically scrub sensitive information from the responses. So while it wouldn't necessarily just block the agent from responding, the response it gives back to the customer may be filtered through. So guardrails are the first thing that you would look into when it comes to stuff like that. So let me show you. I will go into my console, and I will show you how a guardrail looks in this example. Let me show you guardrails. So I have a guardrail here called Robot Vacuum Guardrail, and it basically just has a couple of things. It just prevents a content filter, for example, that will do stuff like denied topics, like the weather, finance, coding help. Like it will actually prevent users from talking about these things specifically, right? So this is a system that's built into the way this agent works. And if I go into my code back again, you will see that there is a setup here that sets up a guardrail. So if my function that's called get model basically sets up my model here, it tells that it uses this specific model, this specific region, and uses this specific guardrail. That means any sort of request going back to Bedrock goes through this guardrail. It has nothing to do with the agent itself. It's not my harness that's doing the guardrails. It is the backend system that's doing the guardrails. It's a way better way for you to control these things. So number one, implement model guardrails. Okay. Let's move on. I do not trust my agents to follow my directions, right? Basically, I can ask an agent, can I get a refund for my order? It's beyond the thing, and they need a refund. An agent, as a helpful agent, will say, yes, absolutely, I'll process your refund. However, it's not that great, right? Basically, a prompt engineering will only get you so far. No tool, no agent can actually do these things precisely, right? Even if they have tools to do that, you shouldn't really do those things, because in this case, an agent may fail or give your customers a bad example, right? It won't a bad experience. It won't actually do what the customer does. So in this example, how is the solution? What's the solution? Well, you can use something called steering, right? Basically, you have agents checking in on agents. You're using an LLM as a judge, right? So when a main agent makes a tool call, a different agent in the back will actually give it guidance based on what it needs to do. Think of it as a glorified skill file, but it's not just a skill file. There's a little bit more of intelligence to it. In essence, it would review the tool call or the request from a main agent and give it a little bit of a better instruction of what it actually has to do in order to fulfill the customer's request. Not only that, but it also reviews the actual response the main agent gets, and determines should it allow it, should it modify it, or should it actually reject it. So having this ability to do this, and steering in this case can be just a centralized location of a, like, for example, your main MCP tool calls will go here, and all of those things will be actually uh, um, checked first. Like, you can have a orchestrating MCP tool layer. In Amazon, in Strands, there is a thing. There is a thing. What did I do here? 1 second. Let me go back to my thing. So there is a feature in Bedrock called plugins. So with plugins, basically there is a specific steering handler here that handles all of these things. So it's part of the Strands SDK that allows you to add specific plugins to it. And in this case, steering is literally just an additional agent that runs before any sort of tool call happens here to determine certain things, right? These are like just reviewing customer service policy. Again, this is still prompt engineering to an extent, but you have a little bit more controls here of what it can do, and your tool itself, your steering agent can also check a bunch of stuff in the back end without necessarily exposing stuff directly to the customer via the main agent. Okay, let's move on. I do not trust my agents with tools and data. So, having your customers check on orders that do not belong to them, or trying to access some information that's not allowed is a challenge, right? So basically having the agent control which values go into a tool call is a problem, right? Having agents, well, basically hallucinate numbers and request IDs is also a problem. So how do you fix having your agent just make a random tool call and hopefully return the stuff? How do you fix your agent not actually leaking data? This is where we go back to MCPs, right? There are ways to implement this using MCP interceptors. An interceptor is basically an MCP tool call, or in my case, it's going to be a function that uses custom authentication and validation logic to basically take the agent's request, pass it on to a backend, and then respond with something correct, right? In this case, this Lambda function will inject the sensitive parameters into a tool call, not the agent itself, but the actual tool call being made to some backend tool, for example, to check the status of an order, would be made by the actual Lambda gateway interceptor, and the data wouldn't be leaked back to the agent. Well, unnecessary data wouldn't be leaked back to the agent. So the Lambda gateway interceptor could also potentially verify authentication, but it would also do some sensitive information that the agent cannot do itself. It's literally just a tool call before the tool call, depending on your system. Depending on your backend system, this may be already built in. Like an example in Amazon Agent Core, which is a platform to run your agents. This Amazon Agent Core gateway has this feature built in. It's called interceptors, but again, you can code your own with hooks or whatnot. So it's literally anybody's call, pun intended. When it comes to the tools, one more thing to add here is that we talked about permissions, but your tools need to be built the way, well, tools should be built. Nicholas, yes, the code is available. I'll share the link in the chat once I'm done. So when it comes to the tools, you have to use tools that will validate inputs, right? You couldn't just put it anything in there. I'm a huge Rust fan. So this example was built in Python, but a lot of the tools I built, a lot of the MCP servers I built are built in Rust. And so, for example, even type safety is a critical thing in Rust tools. So basically, having string validation of inputs. Sensitive values should actually be coming from the system, not the model itself. Your LLM shouldn't be generating sensitive information like tokens and potential data that it shouldn't have access to. You shouldn't probably run shell access or queries through your agents, because that's horrible. I've talked to people who told me that the biggest solution they have, or the best solution they have to agents, is just give them shell access, and it will solve all kinds of problems. Yeah, you shouldn't do that. And like we said in chat, like least privilege for tools is super, super critical. So do multi-tools use only one agent? I mean, in essence, if you're talking about, I don't really understand the question. Maybe you can explain a little bit better for me, Daniel. But multi-tools is, if you're talking about multi-tools, like a orchestrating tool layer. Yeah, I'm not sure, but
You can also unmute Daniel.
yeah, you can also unmute, by the way. So
I will do that. The thing is that I can see here is only multi-tool use pattern is used. I cannot see that there are multiple agents interacting with each other, or did I misunderstand anything?
yeah, well, so there are multiple agents interacting with each other here in an example of the steering agent, right? But it's not your typical multiple agentic orchestration. And like there's not one agent orchestrating multiple different agents. This, since it's a customer support use case, it's a single agent just invoking a bunch of tools that can do stuff, right? In most cases, for these type of things, you don't need multi-agent orchestration, because that will just increase cost and complexity and potential for problems. You should potentially stick with a single context, single agent, and just have a lot of validation on your tool side.
But that is not true, because it can be the opposite. If you have too many tools, it will be costly. If you load all the tools, if you only have one agent and a big context, it will not perform. It will hallucinate.
No, 100%. I agree. I agree. I agree with you. If you have 150 different tool calls, you will run into a lot of context issues. But that's why you scope down your tools for a specific use case, right? And the steering agent can actually present additional tools to the main agent. So like you can have a steering agent that actually determines based on the initial user request which tools it should have access to. So that's a way you can do it. Yeah. Okay. Let's move on. I realize I'm running out of time. I do not trust my agent with high stakes transactions, right? If the model controls all the inputs to your tools, it effectively can control your system, right? So this is kind of a challenge, right? You know, refund me $3,000 or refund me $900, right? What you need to inject here is an ability to say, for example, all refunds over $500 need human approval, right? Or you need deterministic rules to block this specific call, right? Every time a customer mentions $900, there needs to be something happening deterministic, so this specific tool call doesn't get invoked. So in this case, an example is to use something called the deterministic tool authorization. And my example, I'm using an open source framework here called Cedar policies. So you can use Cedar policy enforcement to basically add an policy enforcement layer between an agent and its tools. So if a specific type of tool is trying to be called, well, it's evaluating every tool call. Who's asking? What are they doing? Should this type of thing be involved? And then based off of that, you, do something with it. An example of Cedar policy language, if you have not checked out Cedar policy, I will leave a link as well in the chat, but it's basically an open source policy authorization language that has a specific default deny, but here's an example how this policy language looks like. So you can actually add these things before tools calls are being made, instead of just having them make all kinds of tool calls, especially if you have the ability for your agent to invoke a tool with potentially sensitive data. Okay. I don't have an example of this, but I want to leave this at the end, is that one of the critical things about having agents secure and safe and giving you the trust, or how much trust you can have in your agents or your AI powered applications, is you need to be able to see what your agent is doing, because of the lack of determinism, observability is more important than ever, right? Basically being able to instrument tracing into your applications, identify problems really quick, or potential patterns that are happening within your agents, right? Track down all of the actions your agent took, all of the inputs, all of the outputs, and also, very importantly, set up some sort of anomaly detection. A lot of these features exist built into Agent Core, about Amazon Bedrock Agent Core, but this also applies to no matter what framework you're using. Well, I don't have time to talk about this thing. You need to also build in evaluations, right? You need to be able to check if your agents, what it is doing, and is it doing really well, or if certain changes to your system are making it less or more reliable. So having an evaluation framework is also very critical, that keeps on running to check your systems, check your AI applications from time to time. All the things that I built here, this is kind of the example architecture of what I ran. So clients, Cognito for authentication, firewalls, API gateways, the agent itself running on top of agent core runtime, Cedar policy enforcement for just checking all the tool calls. There's MCP server gateway, basically a gateway in front of all of my tools, together with the interceptor function that serves as this control layer before you actually make those tool calls. All my LLMs run on Amazon Bedrock. My guardrails are running on Bedrock guardrails. I have monitoring on CloudWatch, and I have permissions using AWS IAM, Identity and Access Management. So lastly, when it comes to trust, right? You understand there are different layers, right? From prompts to tools to runtimes to data to network to identity. There's different risks, there's different control layers, and there's also your judgment. Is this deterministic or not really deterministic? Rather, it's probabilistic. So when you're building applications, AI-powered applications, understand these layers. Take a screenshot of this right now and apply these things to different layers of your application, because it is very critical. Again, one thing that's missing here is evals and human in the loop. Very critical for you to understand that certain parts of your AI applications need to have a human in the loop. So try to understand where that is going. Trust is not something you can give to an AI agent, absolutely, because it is a non-deterministic system, but it is something you can build around it. It is something you can use your skills and expertise in systems building and architecture design for you to add the necessary guardrails, tools, checks to your applications, to your AI agents, to actually perform its job really well, because we have something very, very powerful here. We just need to give it the correct environment for it to flourish in, and not burn customer trust, lose data, leak sensitive information, or lose money at the other end as well. Thank you so much, my friends. My name has been Darko. Please feel free to reach out to me. I have a thing you can reach out to me directly. Follow me on socials, and I'm super happy to continue chatting in the chat here as well. I'll drop all the links I have here, and I'll hopefully be able to respond to all of them here. So thank you.